Hello everyone, and in this video we're going to be talking about different types of batteries. As you can see here are some examples of different types of batteries. Now batteries or cells come in different shapes and sizes. However, the larger the battery or cell does not mean that it gives more voltage. In fact, let's take a look at the smallest cell that we have here, which is the quadruple A cell. And this gives out 1.5 volts. Now let's take a look at the larger triple A cell. And this also gives 1.5 volts. Let's take a look at the others. The double A cell gives 1.5 volts as well. Next we have the C-type, and once again it's the same. Now we have the D-type, and once again it's 1.5 volts. Now let's take a look at this strange battery right here. Now this type of battery is called the PP3 type. And as we look at the labeling, this type of battery gives us 9 volts of supply voltage. Now you might ask, where are the positive and negative sides on this battery? On a regular cell, the part where you have this extra material is the positive side, and the flat side is the negative. On this battery, the negative side is where you have this hexagonal shaped clip. The plus side is the circular hole that we have here. Next we have a coin or button cell, and this one gives out a total of 3 volts. The flat side is the positive side of this cell, and this textured side is the negative. Here's something else to take note of. 3 volts from this coin cell are enough to power up a small LED, such as this one. Now here I wish to know the color of this LED, since it has clear packaging. Now remember, the longer lead is called the anode, therefore it's the positive side, and the shorter lead is the cathode, therefore it's the negative side. So let's put the anode on the flat side of this cell, and there you go, you have current flowing through the LED. And this LED turned out to be a white one. Let's try another one just for fun. Here I have another one. So once again, let's put the anode on the plus side. And this one turned out to be pink. This is also a simple method to check whether your cell, your coin cell, has run out. Here we have another small coin or button cell. Unfortunately, here we don't have the voltage marked, we only have the code number. But we'll check how much voltage this one gives later on. Now another way to check whether your battery has run out or not is by using a multimeter. Now a multimeter is a versatile tool which is used to measure voltage, current, resistance. It's also used to check for continuity in a circuit. However, in this case we're going to use it to measure voltage. So let's plug in our probes. Now let's insert the black wire into the common wire input. Now let's insert our red probe. First remove the protective cap. Then insert it through the wire input where you have labeled that you can measure voltage from here. Here we don't have any voltage. Here we only have the current. We have the 10 amp current. And here, as you can see, there's the voltage symbol. Therefore, I'll insert my wire probe into that wire input. Alright, now let's switch it on and turn our dial to measure voltage. Since we're going to be measuring the voltage of batteries, we have to set it to voltage where there's going to be a direct current. Here we have an alternating current. And on the other side, we have the direct current. So this is where we're supposed to put our dial. And it's good to note that batteries, as a power source, they all give direct current. So this is the range where we're supposed to set our dial. Now, since this is a manual digital multimeter, we have to set it to a unit of measurement we're expecting the result to be. So first we're going to start by measuring these batteries right here. And as stated by the label, these are supposed to be 1.5 volts. So let's set it to 2. So 2 volts is the maximum amount of voltage that I can measure right now with the probes. So let's start with the quadruple A cell and check how much voltage it has in real life. Let's see whether it has run down throughout these years. So, the red probe is always to be connected to the positive side, and the black probe is always to be connected to the negative side of your cell. So, place the probes on the proper side and let's see what measurement our digital multimeter will show on the display. Now the display here is showing a total of 1.08 volts. And that means that this cell has lost 0.42 volts throughout the years of usage. Now next we have a AAA cell. Let's check the voltage of this cell. So plus side is where we have the extra material. Let's place the probe there. And the negative to the flat side. So let's see what measurement we're going to have on the multimeter. And here we have a total of 1.568 volts. Let's check the others now. Here we have the AA cell. The plus side is where we have the extra material, and the negative side is where we have the flat side. And place the probes in the proper positions. Then we have the C-type. Now, as you are noticing, some of these cells are brand new. And strangely enough, they never have the exact voltage that is written on the labeling of the battery. Somehow they could be slightly more or slightly less. Now these are brand new. Apparently they are slightly more. In fact, this D-type is about 0.1 volts more than that's what's written on the labeling. Let's measure the voltage of this 9-volt battery. Now make sure where the positive and negative sides are and place your probes in them. Now the multimeter is only showing 1. That is because the multimeter has to be set in the appropriate range of voltage to measure. So here 2 is definitely not enough if we're expecting to see 9 volts. So let's set it to 20. Now we can measure any voltage which is less or equal to 20. So place your probes again. And this battery, throughout its time of usage, has lost about 0.27 volts. Now let's check how much volts this 3-volt cell has now during its time of usage. So probe on the flat side, which is the positive side, and the black probe on the textured side. And here, this coin cell has lost 0.03 volts during its time of usage. So it's basically still almost brand new. Now let's check how much voltage this other coin cell has. Now this one I do not know how much voltage it's supposed to have, so let's check with the multimeter. Now according to the multimeter, this cell has 1.25 volts of supply voltage. However, if you research on the internet, you'll find out that LR44 button cells are supposed to have a supply of 1.5 volts. And that is how to check how much voltage is left in your batteries or cells by using a digital multimeter. Now let's try something different. What if I wanted to have more voltage as a power source? So here I have two 1.5 volt cells. Now let's check how much voltage they have. In reality, I am going to change this one to a more new one. Let's check the voltage again. And all of them are about 1.5 volts, or slightly more. Okay, so if I wanted more voltage in a circuit, all I have to do is connect these two cells in series to form a battery. Because as we all know, 2 or more cells make a battery. Now we connect cells in series this way. First you're going to have the positive, then the negative, and to that negative you're going to connect the positive of the other cell. And connected this way, you have 2 cells connected in series to each other. Now let's check the voltage with the multimeter and see if we'll have more voltage. So, black probe to the negative side and red probe to the positive side. Now, of course, I forgot. Let's change the range of the multimeter because now we're going to have more voltage. And there you go. So 1.5 volt cell and another 1.5 volt cell will give me 3 volts. Now since these both had a little bit more voltage than described in their labeling, we've ended up with having 3.08 volts. Now let's add another cell just for fun. So 2 cells in series give me 3 volts. How much voltage will I have if I were to add another cell? So let's measure the voltage of this cell. And here we have a total of 1.46 volts. So let's connect it in series with the other cells. And there you go. When we have 3 AAA cells connected to each other, we'll have 4.5 volts. Okay, now that's it about batteries and how to measure their voltage.